I'm going to go over the odd problems of the Math 3 Unit 6 Worksheet 1, starting with number 1. We have the square root of 49, that's 7 times 7, and m. But when we take the square root, we need to make sure we have a positive answer, and we don't know if m is a positive, represents a positive number, so we put absolute value around it. Number 3, square root of 121 is 11. M to the 6, we have 6 m's, and so we have 3 groups of 2. And 8 n's, we can group that in 4 groups of 2. Again, we need to make sure our answer is positive, and we're not sure if m cubed is positive in this case, and so we're going to put absolute value around that. Number 5 is cube root of 8. 8 is 2 times 2 times 2. And so we have a set of 3 things, so we get 2, and we also have 3 m's. And take the cube root of that, you get m. We do not need a positive answer here, so that's our answer. Number 7, 80 we can break down to 8 times 10. 8 is 2 times 2 times 2. 10 is 2 times 5. We're looking for pairs, so we got 2 pairs of 2, and m to the 4th, n to the 5th. So we have 4 m's, 5 n's. Looking for pairs still. And so we can get 2 times 2 times m times m times n times n. That's what we could take the square root of. And we're left with 5n. So 4m squared, n squared, square root of 5n. And everything that we took the square root of, we know we get a positive answer. So that's our answer there. Next, number 9. We want to rationalize the denominator, so we need to multiply by the conjugate of the denominator, which is root 13 minus 2 over root 13 minus 2. And when we get that, we distribute, and we get 18 root 13 minus 36 over root 169 minus 2 root 13 plus 2 root 13 minus 4. Keep working on simplifying this. The middle 2 terms here add up to 0. And this is square root of 69 is 13. So we get 18 root 13 minus 36 over 13 minus 4, which is 9. And then we can reduce this fraction dividing by 9. So 18 divided by 9 is 2, so 2 root 13. And 36 divided by 9 is 4. Number 11. We have 5 over the cube root. I'm going to break this up. We have 5 times 5 times x times x. And to take the cube root of something, you need a set of 3 things. So I'm going to multiply by the cube root of 1 more 5, because I already have 2, and 1 more x. Top and bottom of that equation. And we end up with 5 cube root 5x over cube root of 5 times 5 times 5, x times x times x. So now we have perfect cubes that we can take the cube root of. So 5 cube root x over 5x. And then we can reduce. We could divide by 5 and get cube root x over x. Number 13, square root of 7x. In the denominator, we need to rationalize that. So I'm going to multiply by square root of 7x over square root of 7x to create a perfect square in the denominator. And we end up with 3x root 7x over root 49x squared, which is 3x root 7x over 7x. And divide top and bottom of the fraction by x, and you end up with 3 root 7x over 7. We're going to skip 14 actually. 15. Here we're going to break down the square roots. 75 is 25 times 3, and 25 is 5 times 5. We got a pair of 5s there. We have 1m and 6 n's. So 3 pairs. 48 is 16 times 3. 16 is 4 times 4. We got 3 m's. And oops, we're looking for pairs, not sets of 3. And 2 n's. So our first term, we already had 4m in the outside, and we're pulling out a 5n cubed, and we're left with the square root of 3m minus, we already had a 2n squared times 4mn times the square root of 3m. This gives me 20mn cubed square root 3m minus 8mn squared square root 3m. We could subtract these. 20 minus 8 is 12mn cubed square root 3m. Number 17. Going to multiply these together, we get the square root of 27x to the 5th, y to the 6th. 27 is 3 times 3 times 3. Got a pair of 3's here. We have 5 x's, so we can create 2 pairs here, and 6 y's. And so we end up with 3x squared y cubed times the square root of 3x. We're to rewrite the functions below so they are translated 5 units left and 7 units up, and then sketch the translated function. So if I translate 5 units left, this is going to be y equals x plus 5 squared, and up 7 units. And so 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7. And this is a parabola, something like that. Now we have another parabola. We want to move 5 units left, so I need to add 5 to the already negative 2, and I need to add 7 to the 3 here, and we end up with y equals x plus 3 squared plus 10. And so if I graph that, I'm going left 3, up 10. Again, a parabola. Opening up. Part C, 5 units left, and 7 units up. So there's the vertex, V shape, opening up. Slope of the right side's 1, slope of the left side's -1. And last one, we're going to move it 5 to the right, so we're going to add 5 to that +2 and add 7 to the +1. We get y equals x plus 7 plus 8. So left 7, up 8. Again, a V shape. Right side has slope 1, left side has a slope of -1. E, 5 units left, 7 units up. Square root function. 5 units left, 7 units up. So we end up with y equals the square root of x plus 6 plus 5. So we actually, from 0, 0, we go left 6, up 1, 2, 3, 4, 5. Cube root function. Left 5, up 7. And lastly, add 5, add 7, we end up with y is the cube root of x plus 4 plus 6, so we end up going left 4, up 6. We have it. Number 21. Given f of x equals the square root of x and g of x is x minus 3, sketch y equals f, negative f of g of x. So we're going to plug in g of x in the x value for f, and put a negative sign out in front, and we end up with y equals negative square root of x minus 3. We identify the domain and range and have a nice sketch here. So from 0, 0, I'm going to move left 3, right 3. And this is going to open down to the right because of we have that negative sign out in front. The domain is from 3 to infinity, and the range is from negative infinity up to 0. And if we want to get some more points for exact points here, we can pick some x values in a table and work through this. So we know there's no points outside the domain, so we got to pick 3 or greater. We already know the point when x is 3, so if I try 4, I end up with negative square root of 1, which is -1. So we know it's going through the point 4, -1. If we try 7, we end up with -2. So about right there. Alright, 23. Solve the following equation for x. So here, first step, make sure you isolate one of the square roots. We did. Second, get rid of the square root by squaring both sides. When we do that, we get 2x plus 10 is 4x. I'm going to subtract 2x from both sides and get 10 is 2x, divide by 2, get 5 is equal to x. And then last step, let's check to make sure that works. So is the square root of 2 times 5 plus 10 equal to the square root of 4 times 5? So we get root 20 equal to root 20, which is true, so we keep our answer, x is 5. 25, we're asked to solve the following equation algebraically, and then part B we work at it graphically. So starting algebraically, I'm going to square both sides and get x minus 2 is equal to x minus 4 times x minus 4. Distribute, you end up with x minus 2 is x squared minus 4x plus 16. Make the left side equal to 0 by subtracting x and adding 2 to both sides. And then work on factoring. We're looking for two numbers that multiply to 18 and add to negative 9. X minus 3 and x minus 6. Set each factor equal to 0 and we get two answers, x equals 3 and x equals 6. But we need to check to make sure these work. So if x equals 3, we get the square root of 3 minus 2 is equal to 3 minus 4, where the square root of 1 is negative 1, which is false. So we need to throw out that answer. And then check again for 6. And we get the square root of 6 minus 2 is equal to 6 minus 4, which is the square root of 4 is 2, and that's true. So we keep x equals 6 as an answer. For part B, we need to write the above equation as a system of two equations and graph. So let's let f of x be the left side of that equation, and the right side be g of x. And we know from our solution in A that those two graphs should cross when x is 6, because that was our solution. And so let's check that out. So first of all, g of x is a line, crosses the y-axis at negative 4, has a slope of 1, and f of x, square root function, starts at 2, 0, and I'll get some points here for that one for f of x. So maybe we'll go with, so we know what happens at x equals 2, let's try x equals 3. End up with square root of 1, which is 1. And then let's try 6. We get square root of 4, which is 2. And we see that the two graphs cross when x is 6. Next, I'm going to do 27. And we're asked to do a number of things here. Graph the following, find A, the x and y intercepts, B, the domain and range, C, the open interval where f is increasing, and so on. Okay, so let's take a look here. So for 27, first of all, it's important to realize that this is equivalent to negative root x plus 3 plus 4 at the end. So maybe it's helpful to see it that way, to know that the translation is to the left 3 units and up 4 units from 0, 0. And we know this is opening downward. And I'll get a few points here. So we know what happens when x is at -3. So let's try -2. We get 4 minus the square root of 1, or 4 minus 1, which is 3. And then let's try when x is 1. We get 2. So it's dropping slowly to the right. Now let's answer our question. So for part A, we want to find the x and y intercept. So for the x-intercept, plug in 0 for y and solve. So 0 is going to equal 4 minus the square root of x plus 3. I'm going to add square root of x plus 3 to both sides here. Square both sides. And get x plus 3 is 16. Subtract 3 and you get x is 13. And if you check that, it turns out that's true. So that's our x-intercept. Our y-intercept, plug in 0 for x this time, and we end up with f of 0 is 4 minus the square root of 3, which is a decimal value. And we see in our graph it's going to cross the y-axis somewhere between 2 and 3. So that's as much as we can do for part A without a calculator. Part B asks for the domain and range. Okay, so I'll put part B here. The domain starts at -3, goes to infinity. The range is as low as -infinity all the way up to a height of 1, 2, 3, 4. So that's part B. Part C says what's the open interval where f is increasing, and part D is the open interval where f is decreasing. So for part C, it's increasing nowhere. In part D, it decreases everywhere over its domain. And they want the open interval, so we'll use parentheses only, so from -3 to infinity. Part E, the open interval where f is negative, so that means below the x-axis. In this case, it starts above the x-axis, and when it hits the x-intercept, which is at x equals 13, and everything beyond that is below the x-axis, so it's negative from 13 to infinity. F, where's the open interval where it's positive? Well, it's positive when it's above the x-axis, and it starts at, its domain starts at -3 and goes all the way to the x-intercept at 13, and that's where it's above the x-axis or where it's positive. And then G, for problem, should say number 27, it says 7, but it should say 27. We want to work on the interval from -2 to 1. And those are in our chart here already, so we know these points already. So from -2 to 1. And we have these points. When x is -2, its y value is 3. And when x is 1, we get a y value of 2, seen in our table and our points that we graphed. And so G again is asking for the average rate of change. The average rate of change is your slope, and so you use that slope formula. You subtract your two y values in the numerator and your two x values in the denominator, and pick which direction you want to go. So I'm going to go negative 2 minus 1 over 3 minus 2, which is negative 3 over 1, or negative 3. So the average rate of change is negative 3 from the point negative 2 to 1. And actually I caught my error here. I put in the wrong values for x and y. So let's try that again. Y values 3 minus 2, x values negative 2 minus 1. So that gives us 1 over negative 3, or negative 1/3. Number 29, determine whether each expression is equivalent to 32x cubed y squared. Select yes or no for each expression. So here 32 is 2 times 16. 16, 4 times 4. We got 3 x's and 2 y's. And so we end up with 4xy square root of 2x. Now, if it doesn't state what we're assuming about our expression or our variables, it doesn't state that we have positive values, and actually if you look at the answer choices, absolute value is being used, so we know we're probably not assuming that x or y are positive or negative particularly. Next thing is, do we allow for imaginary or not? Are we just talking about real expressions or complex expressions here? If we're just allowing for real expressions, then we're not sure if y is positive or negative, so we need a absolute value, because underneath the square root we have y squared, which anything squared is positive. And then we have this x cubed, which is an odd power, and so we'd need x to be positive, so we wouldn't have to put an absolute value around the x. Now if we worked with the complex expressions, then we wouldn't know about x or y, and we'd say 4 absolute value of x and y square root of 2x. So I'm going to assume the first. Okay. And so if that's the case, we see the answer in the third row, and we want to compare the others, because the other ones may not be fully simplified, but we do know we would need that absolute value of y, and so we'd have to say no to the second row because we don't have the absolute value of y. The first row, they just kept the y squared underneath the square root, so that is exactly the same, just not as simplified. The fourth row, we do not get a 4 out in front, so that's going to be false. And the last row, if we simplify that 8, get 2, pull 2 2's out, we're left with 1 2 underneath. We got the absolute value we want, so that's going to work out as well. So that's how we want to select yes and no, based on assuming real expressions only. Okay, here 31 through 35 we're matching, and I'll do some of the odds. So 31, we're looking for a square root function that is positive, and so it's increasing, and it starts at 2, -1, and so 31 looks like it goes with B. Okay, 32 is decreasing because it's got the negative in front, and again starts at the same location, right 2, down 1, and it's just the square root, and so that would be E. 33 is a cube root function, and it starts at, its center is right 2, down 1, so that would be H. And 34, we have a square root function decreasing, starting at left 2, down 1, that would be C. And 35, we have a cube root function reflected about the x-axis, and starting at left 2, down 1. So that would be F. We're asked to solve for x, and I'm going to start by dividing both sides by 3, and you get the square root of 5x plus 4 equals 2 times the square root of 2x. Now I'm going to get rid of the square roots by squaring both sides, and we have 5x plus 4 is 2 squared, which is 4, times 2x. Subtract 5x from both sides, we have 4 is 3x, divide by 3, and x is 4/3. (39) says to go back to 38. Rewrite the equation as a system of 2 equations and graph both on the coordinate axis to the right. Find the solution or solutions to the system based on the graph. So let's let f of x be the left half, which is square root of x plus 3, and g of x be the right half, which is negative x minus 1. And I'll start by graphing g of x, which has a y-intercept at -1 and a slope of -1. And then f of x, from 0, 0, I'm going to move left 3. And let's find a couple values for this. So we know what happens at -3. Let's try -2. We end up with 1. And we know it looks something like this. So we see where they're crossing, and so our solution, well, if we put it as a coordinate, would be at -2, 1. If we're just thinking about the x value, you could say, well, it's just that x equals -2, which should be the same solution as 30 to 38 when you solve that algebraically. Lastly, number 41. If we have this function, find its domain and range. So if we just make a very quick sketch of this, I'm going to go right 2, down 7. and it opens down to the right. So our domain starts at 2, goes to infinity, and our range goes from negative infinity up to a height of -7.